So for this problem, we want to find the electric field, both magnitude and direction, a distance z above the midpoint between equal and opposite charges plus or minus q, a distance d apart, same as example 2.1, except that the charge at x is equal to plus d over 2, which is q. So first we want to start by drawing our charges. So we have our z-axis, our x-axis, and our y-axis. So this is our y-axis, so our x-axis is our z-axis. And we have plus q, negative q, which are a distance d apart. So that means this is d over 2, and this is d over 2. So next we draw a triangle. So next we draw an equilateral triangle. Split down the middle. Well, both of these are d over 2. So that means the hypotenuse is d over 2 squared plus z squared, the square root of that on both sides. So now we want to use the principle of superposition to find the electric field, a distance z above the origin, which is here. Note that r is the position vector to where we want to know the electric field. And then we have also a position vector to charge qi. And our superposition vector would be cursive r, which will equal r minus ri. And that's going to be the position vector from the charge qi to where we want to know the electric field. So then we use our equation. We have E is equal to 1, 4 pi epsilon naught I 1. We only have two charges. Qi over our superposition vector. Our superposition vector hat I. We can further simplify that to 1 over 4 pi epsilon naught I is equal to 1. Like again, we only have two vectors or two charges. Qi over our superposition vector r minus r I over our superposition vector. That then gives us 1 over 4 pi epsilon naught 2 equals 1 qi over our superposition vector cubed times r minus r naught I. And that finally simplifies to 1 over 4 pi epsilon naught I equals 1 to qi. So now we just want to just expand the sum, plug in the vectors and simplify our results. So we get E is equal to 4 pi epsilon naught times our vector 0, 0, z minus 2 square 0, 0, z minus r2. And that can be further simplified to 1 over 4 pi epsilon naught plus q over the square root of d2 over 4 plus z squared cubed times our vector 0, 0, z minus another vector d2, d over 2, 0, 0, plus negative q d squared over 4 plus z squared cubed times our position vector 0, 0, z minus d over 2, 0, 0. After further simplification, we get 1 over 4 pi epsilon naught times q over d squared over 4 plus z squared to the 3 halves times our vectors 0, 0, z minus negative d over 2, 0, 0 minus 0, 0, z plus d over 2, 0, 0. And once we further simplify that, we get 1 over 4 pi epsilon naught times q over d squared over 4 plus z squared all to the 3 halves, times the vector d 0, 0. We then get 1 over 4 pi epsilon naught times q over d squared to the 4, d squared over 4 plus z squared to the 3 halves times the vector d. Plug in 1 for z. 1 for d. 0, 0. Ultimately, we get 1 over 4 pi epsilon naught times qd over d squared over 4 plus z squared raised to the 3 halves x hat. And that will be our final answer. Thank you for watching this video.